First of all, it's my great privilege to be here, and I am so very grateful to the organizing secretary and also to Dr. Shakti. He is not here. Somebody can convey him later. So this is a heritage building of King George's Medical University, more than 100-year-old hospital. Total bed strength 4,500, unofficially 5,000. So the important issues in management of services in a hospital, if we see the important issues, you will agree that one of the important issues is cost of energy is very high. Second, it is difficult to maintain controlled environment because of so many problems, maintenance problems, breakdown, and things like that. Deficiency of human resource, it will always be there, especially for maintenance works. Poor workflow continuity. Somebody goes after the shift, the complaint also goes with them. So continuity is hampered. There is delay in detection of things like fire incident. These are the major issues when we talk about any hospital. Then we also talk about something like green hospital, the intelligent hospital building. You are walking and lights are getting on and off. Then smart hospital, that is safe hospital plus green, that is the smart hospital. Now you take any variant, or you take a standard hospital, or you can take any of these variant. If we can support with a building management system, the hospital can be very, very effective. So let us see what is a building management system. Now, an integrated building management system includes centralized monitoring and control of various services which you are providing in the hospital through an automated system. So centralized monitoring and control, that means your engineering department, somebody is sitting there, chief of engineering department, and he is handling all the services while sitting there in his office on a chair. That is the integrated building management system. This will obviously result in conservation of energy as well as conservation of manpower and efficient management of services. Now, integrated building management system includes electronic and electromechanical controls for all items, and that will include things like dampers, the valves, motors, and other peripheral devices. We have microprocessor based station controllers interfacing directly with field devices like sensors, valves, and air conditioning systems like chillers, EHUs, pumps, fan coil units, fans, electricity devices, and so on. It also includes communication network to allow data exchange between the individual station controllers, which are microprocessor based. I'll just go very briefly, not go in the detail. Now this system includes control cables from field devices control. It includes control cables from field devices into the direct digital control panels. You have direct DDCs with you, direct digital control panels, and from these panels you can operate. You can make them functional or you can switch them off while sitting in the office. And it can integrate with fire safety system. It includes various appliances for service functions. It has a control system or control unit for regulation of appliances. There is a communication bus which connects your peripheral devices with the control unit, and transponder permits a two-way communication. For example, in this, you have all sorts of appliances, the electrical devices or your EHU, chiller, HVAC system. There is a control unit or control panel, DDC, and these are communicated with the help of communication bus, and transponder allows a two-way communication. Transponders, I said, it permits you a two-way communication. Now, same thing in a pictorial form. You have all these devices. You have fans, electrical devices, heating appliances, HVAC system. Then there is a control unit, and there is a communication bus here, and the transponder will allow a two-way communication. Do you want to increase the air pressure, or you do not want to increase the air pressure? You have a two-way communication where the pressure is less, where it is low, and while sitting on the control unit, you are doing that. That is the integrated building management system. Now, the question is, what services can be integrated? We can integrate HVAC system, the fire safety, lighting control, disaster management to some extent, CCTV, access control, the lifts, public address system, individual room controls. Now somebody is admitted in ICU in a cubicle, you can control it from the office of the engineering department. Similarly for operation theatre and the electrical power control. Let us briefly see about the HVAC system. Now, HVAC system accounts for nearly 60 to 65% of your hospital's electrical energy consumption. With IBMS, roughly around 20 to 25% saving can be achieved. Now with BMS, we can have individual control, we can switch on, switch off a particular chiller or EHU, we can adjust the cold water temperature, we can control the capacity and the pressure, we can also control return water temperature, alarms, and action taken to resolve the issue. So there is no need to go to machine. While sitting in the office, you can do it, and that is how it conserves the manpower. Now, in case of AHU, it maintains occupancy setbacks. If people are more, then it will conserve the energy. It will provide more energy. If people are less, it will conserve the energy. Maybe it will switch off many of the devices leaving only the compressor. By integrating HVAC system creates tighter control in occupied areas and saves energy in unoccupied spaces. Thus it will improve the temperature humidity. We can have CO2 sensors with integrated building management systems, and CO2 sensor can determine ventilation need and measure CO2 concentration in ventilated spaces. It is used to control the amount of fresh air supplied. How much fresh air you want to supply to your critical care areas, to operation theatre or ICU. So it can happen with the help of CO2 sensors, which will be a part of building management system. Or we can have humidity temperature sensor with controller to control humidity and temperature while sitting in the office. Temperature, humidity of any operation theatre in a multi-storied building can be controlled by somebody who is sitting in the engineering office. We have dry media sensors, a part of building management system for measurement and control of differential air pressure. You will appreciate that there are many facilities where we have a zoning system, like operation theatre, we have zoning, ICU, we have zoning, in any of the ward, we have zoning, patient areas, ancillary areas, auxiliary areas, sanitary areas. That is how we create the zones. PASA is the formula for students to remember. Now, this dry media sensor, they help in maintaining the differential pressure. Operation theatre zoning is not only created by the design of the operation theatre, but also it has to be supported with the HVAC system. If this most sterile area has more pressure, in operation theatre it should be 24-25 pascals, in clean corridor it should be 14 pascals, and in protective area it should be 5 pascals. Only then the air will flow from OT to outside, and this can be done with the help of dry media sensors. So with integration of building management system, all above parameters can be controlled or manipulated from the control room over a dashboard. You don't have to go anywhere else. This is a part of
Welcome to Take a Middle East Programming Room. I hope you are doing well. In this video we will talk about HVAC system. This system contains of boilers, chillers and AHUs. For this system we have two modes, heating and cooling, and we have manual and auto mode. We will talk in a later videos for boilers room, fan coils and chillers room. Here we have the space. Here we can find the temperature of the space. This system works to reach a set point set by user.
The set point.
Let's take an example for it. Let's say 45. We see that the boilers turn off and the heated air will come to space, and we see here also the space temperature is increasing. After reaching the set point, the boiler will shut down and the hot water will continue by this pump. We see that the fresh air is coming from this dump. We can control each dump of these 4 dampers. Let's discuss some cases. For CO2 level, if we have a high CO2 level, let's say 50, we see that dumper number 3 and dumper number 4 are closed. So only the fresh air will come to space, and the CO2 will go from this dumper, the exhaust dumper. Okay, let's see another case. If we have a humidity that reach lower than 40%, as we see here, the humidifier is working. If it's higher, let's see 50, it will turn off and the air is very useful to come to the space. Let's discuss some fault cases and error messages. If we have a problem in differential pressure sensor or filter 1, let's see what we got. We see that we have a signal that shows that the filter number 1 is dirty and we need to clean it. Also for filter number 2, it will indicate about it's dirty. And now for the fan, if we have a problem in differential pressure sensor, let's see what we got. First of all fan will turn off and an error.
So what I wanted to tell you is that this all is happening when you are sitting in the control room. You can change the temperature. You can even monitor the filters. That is what has been shown to you. You can increase the fresh air component. This is what you will have in the control room. Now let us come to the fire safety system. Fire safety will have fire indicating device, that is a smoke detector. Then we have a centralized control panel that takes the inputs from indicating devices, that is a smoke detector. Then fire notification device that indicates a fire to facility occupants such as PA system, alarms, etc. And then we have fire mitigating device, that is water sprinkler system. Now this is what you will have in your control room. You have a fire control panel and that will be linked to all detectors and the water sprinkler. While sitting in the office, you can see which detector is working, which detector is activated, where is the fire alarm, which fire alarm is activated, and accordingly you can take the action and send the team. On detection of fire, one or more of these actions can be initiated. So you can detect the fire while sitting in the office. We can see the location of fire in a multi-storied building. It becomes very, very easy. We can identify by location of alarm while sitting in the office. The concerned air handling unit can be turned off, otherwise the fire will rush through the air handling unit in the duct. The fresh air dampers and supply fans can be closed. More air, the fire will further become more aggressive. We can unlock all doors, provided access control is also a part of building management system. The system can bring the lift to ground floor. We can integrate the lift also with the building management system, and at the event of fire, the lift can be brought down to the ground floor. Fire lift brought to fireman mode, it can be brought to fireman mode. We can turn on all emergency lights and we can notify to first responders, and all this with building management system. Water sprinkler monitoring and control can also be done. The system can automatically make an announcement to occupants to start for evacuation. And all these things, alarm reset, testing and all, can be done. A few words about the energy management system. It can track and allocate energy usage on a real-time basis. It can monitor energy consumption to ensure the facilities operating within set parameters. Thus, we can maximize the saving with conservation of energy. There will be no compromise on comfort, safety and security. Energy saving devices can be well integrated with building management system. We can have a proper schedule of AHU maintenance, installation of timers in air handling units, installation of variable speed air conditioning motor drivers, installation of flow and volume restrictors. All this can be done with the help of BMS while sitting in the office. Let us see what it can do for the disaster management. Now this is the hospital building and this is the base. When we make a provision for isolation of the base, what we do, we create a plate. We create a isolation plate on which hospital building comes, and this remains the base. The building management system is utilized to activate this plate. This plate is activated only when there are warning about the earthquake or whenever it is required. Like you will see in this case, base isolation. There is a very highly tensile rubberized plate on which the entire hospital building rests. That is what we do in base isolation. It has steel, and over that we have a covering of very high tensile rubber. Normally, like I showed you in the plate, the entire building will go down and dip in this plate. At the time of a disaster or the earthquake, we activate this plate, and if at all the hospital building undergoes earthquake, this base plate will move like this without any adverse impact on the hospital building. You have seen the rubber moving in horizontal direction. So that is what is integrated with the building management system. Then we have the controlling of lights. The monitoring and controlling of light can be done. We can switch off and on various lights of the hospital with the help of the building management system. So imagine in a multi-storied building, wherever you want to switch off, switch on the light while sitting in the office, with integration of BMS you can do it. Volume, the light controls and control of even window blinds. CCTV and access control, it's very easy to be integrated with the building management system. Now the advantages, as you have seen, we can have a central monitoring and control of key building systems. Direct savings due to energy conservation through controlled building system will happen. Reduced labor and maintenance costs. We don't have to run around to the entire multi-storied or spread out building. There will be reduction in lost time or downtime. Calls can be immediately attended. Better property utilization. Safe environment can be provided. Another important aspect is that we can validate the specialized services. For example, HVAC system of operation theatre. We can check while sitting in the office whether it is providing 20 to 25 air changes per hour, whether filters are working, what is the temperature, what is the humidity. So all that we can validate while sitting in the office. So in nutshell, you see here, this is prior to installing building management system, and this is after installing. So here improper switching due to non-optimized scheduling, proper switching by optimized scheduling, and energy saved is roughly around 30-35% in this. Increased manpower cost due to manual intervention. Here our solution takes total control, no manpower running around. Higher maintenance and repair cost due to proactive, reactive monitoring. And here maintenance and repair cost reduction due to proactive monitoring. Large amount of CO2 emission pollutes the environment, more than 50% reduction in CO2 emission. So these are the advantages of IBMS. Thank you very much.
Thank you, sir. Now the session is open for discussion.
Sir, should it be possible to implement in an already existing building?
Certain parts can be implemented. It is possible.
Then what would be the cost factor about it?
See, cost will depend on many issues. How much, what is the size of the hospital building, what areas you would like to integrate. So for that really a study will be required. Only then the cost can be commented upon.
I shall bite you with my white teeth, replied the mouse.
And helps me with my
We'll come to the last
Hi, Mama.
session for conference.
Company